this is the Thunderbolt. The Thunderbolt is a 2-plate EIA processor. As you can see, there are places for 2 96 well plates to be placed on the instrument, as well as an extra pre-dilution plate if needed. You will see in a little bit why we are able to run many different tests that require large dilutions and pipette directly into the wells, and therefore do not need the pre-dilution plate. We're going to start at the bottom. Down here we like to call this the intelligent rack tray. These are sample racks. These are where you will place the 192 samples that you could run on your 2 full plates if needed. This is also where your calibrators and controls will be placed. In the back here, there are reagent adapters inside of a reagent rack. These reagent adapters are all customizable. We make these so that you can open your kit, take the bottles that come in the kit and put them directly into the instrument. Once again, we're just trying to simplify your experience and not make it any more complicated than it needs to be. If the reagent adapters don't fit the specific size of reagent bottles that you have in your kit, we can actually custom make those as well as the sample racks. The sample racks come in sizes of 12, 13, and 16 millimeters for all of the standard clinical lab testing samples. Those can also be custom made for your lab if you have odd-shaped tubes. Now, one of the important features of the intelligent rack is the positive sample identification. When scanning in samples, our system does not force you into using a rail system where everything must be placed in the correct order. In our system, you can custom load your samples how you like. We're going to manually enter a sample. Let's say we're going to type in our sample Scott, and that we want to place Scott here. That is where Scott is located. You do not have to load Scott in a fixed location every single time. You can put him in a different spot. Now let's say we want to load sample Tina. You can load Tina here. They do not have to be in order. The instrument will positively identify that sample with that location. You can see that on the Racks tab on the screen. Now, let's say you have a barcoded sample. With the barcoded sample, you simply scan and place. And that is where that sample will be located. Scan another sample, place there. So there are 3 main ways that you can load samples. There's the barcode scanning, which you just saw, the manual entry, which you just saw, and then auto increment sample ID. That is used mostly during validations. Okay, we'll click finished. And as you see, the locations of the samples that you just placed, both using manual entry and barcode scanning, are in the sample racks exactly where you placed them. They do not have to be in any specific order. Now, if you don't care to use the intelligent rack feature, you can turn that off and simply load them starting from the first location in sample rack 1, then moving to sample rack 2, and then to sample rack 3. The instrument works in both ways. All right. You will also see on this reagent rack is a wash cup, as well as a calibration cuvette. The calibration cuvette is just used for service PM reasons and does not need to be, the user does not use it in any way. And the wash cup, however, is a very important feature that allows us to clean off our probe. Now, with that said, I'm going to move up to the probe. Our probe is a single probe dual needle system that accurately can pick up all the way down to 1 microliter with a 3% CV across a full plate. The reason it's able to do that is that we have a micro syringe, which is located directly above the probe. That micro syringe is responsible for picking up all the small volumes, so from 1 to 40 microliters. We have a macro syringe that picks up everything above 40 microliters. Like I said, all critical volumes are picked up with a syringe. The reason we do this is because peristaltic pumps are inherently variable. They change over time, they change with temperature, and they do, we do use them on our instrument, but we use them for the wash pump only and for the waste pump. So they will be helping to deliver wash to the wells because that volume is not as critical. Then let's say a 20 microliter sample dispense into the well. That's a critical volume and it must be accurate. Also on the probe assembly, you will see the camera right on the front. That camera is a really unique feature that we use to remotely diagnose any problems that are going on in the instrument. So we can log in and see what's going on both on your computer, on the software, as well as what's going on the inside of the instrument by looking on the status tab and watching what the camera is doing. As you can see, the camera is a live feed right there. Now, the other unique thing about the probe is that it is very difficult to break. The probe is not actually driven by the motor. The probe simply rests on a nut which is driven by the motor. So if the instrument is moving and the probe descends, you can actually stick your hand in there and not damage your hand. This also prevents you from damaging any caps or damaging the probe on any caps that are forgotten. The other great feature is that it's a snap-back probe. It's held on by a magnet, and so if something hits it on the horizontal plane, it will snap back into place. Now, the way that the probe detects liquid is through a conductance system. So like I said, it's a single probe dual needle. Both of those needles serve as the conductance probes. So when they are in liquid, it closes the circuit and tells the probe that you are in fluid. The reason that we have such a great liquid sensitivity level is that we have a very sensitive liquid detection system. We use a direct current system that the instant it touches fluid, it signals the system and tells it what to do. So we can pick up lower volumes from lower dead volumes than any other instrument on the market. Our dead volumes for samples is anywhere from 100 to 150 microliters, and our dead volumes for reagents are anywhere from a half a mil to a mil max. Now these all depend on the type of sample tube, but I've seen anything as low as 1 microliter being picked up out of 30 microliters in the bottom of a 12 millimeter tube. So like I said, one of the best in the market. Now the probe is a single probe dual needle system. Now you might wonder, well, how then do you wash the plate? Well, the answer is that we wash the plate using that same probe. Now the single probe system, yes, it means that we will have to then wash with that same single probe, but we have chosen to do that on purpose. And the reason is that we can then treat every well identically. There are many other systems on the market. They have a single probe liquid handling system, but then a full strip washer. However, in a situation like that, you're never going to get the timing exactly correct. Therefore, a 30-minute conjugate incubation, then a wash, then a dispense of a substrate is always going to be off by a little bit because assumptions and estimations need to be made. With our system, every single well will be treated identically. So if it takes 10 minutes to process the washing step, every well will sit for 10 minutes. If it takes a half an hour for a conjugate incubation, every well will sit for exactly 30 minutes. To us, we believe that this is the correct way to be processing ELISAs. So just as we process samples, reagents, and washing the wells well by well, we also read well by well. I'm going to bring the reader out here. And the other great thing about our reader is that it's a patented LED technology. This allows us to have all the features of your normal benchtop spectrophotometer, but in something that is the size of your fist. Once again, this allows us to keep our footprint the smallest on the market. Now, as you see here, it is reading well by well. We can read across the full plate in about 2 minutes, and we have 5 different wavelengths on that reader. There are other wavelengths available, and as you prepare to order your Thunderbolt, we can discuss what those wavelengths will be. But the main thing about the LED reader is that you have the benefits of LEDs. LEDs last much longer, are much brighter, are more robust, have faster on and off switches, and allow us to provide you with the most reliable reader on the market. Now, just as we're able to keep the footprint smaller with a small compact LED reader, we also do not need a chamber for an incubator. We do our incubating directly on top of our microtiter plate carrier, where you see the 2 microtiter plates. Now, as I take this off, you will see holes. Those holes are for the reader, so that the reader can read well by well. Now, the other things that you see on the plate are resistors. Now, they're on the microtiter plate carrier. So those resistors heat directly under the well. We can heat up to 40 degrees Celsius, and we can independently heat the left plate or the right plate as needed. Now, the greatest part about our convection style heating is that we are able to heat evenly across the plate. Within a chamber incubator, not only are you taking up more space with a large chamber, but you are ultimately going to have edge effect. On a 96 well plate format test, the outer wells are exposed to more of the atmosphere within the chamber than the inner wells. On our system, every single well is heated by the same number of resistors beneath it. So across the whole plate, you will get an even distribution of heat. We also have air that is being blown through a pump here that comes up through the resistors and allows the air underneath to be homogeneous. Now, on the same, once again in keeping with the theme of small and simple, right on top of our incubator, we put the shaker. So as you see here, there are two posts. This is our shaker. Our shaker has an amplitude of 1 millimeter and can shake up to 900 RPM. The reason I mentioned the amplitude of the shaker is that you can put 300 microliters of reagent into a well and shake it at 900 RPM, and because of the tight amplitude, you won't be cross-contaminating any of the wells around it. I will turn that on for you now. Now this is an example of a 350 RPM shake. Let's go to 900 just so you can see that. As you see on the far left side, that is where your wash bottles will go for each of your tests, as well as the waste bottle. Now, I want to speak more generally about the system and go over some key features. One of the biggest features of our instrument is its size. It's essentially a 2x2 footprint. It sits on any bench top and can easily fit into any lab. We have a small netbook that sits on a pedestal on the right side of the instrument, which allows you full functionality of the bench space below it. The other things, is the main one to me, is the probe. Our probe can pick up 1 microliter, and because of that, we can perform 1 to 100 dilutions directly into the well. Many tests, including most infectious disease tests, involve a 1 to 100 sample dilution. Those samples can be diluted directly into the wells, and the timing starts the second the sample and diluent hits the well. Therefore, we skip past the whole start of most tests, which includes an instrument picking up diluent, dropping off diluent, picking up sample, dropping off the sample into the diluent, mixing the diluent in the sample, then transferring the diluted sample to the plate. Now, because we can dilute 1 to 100 directly into the well, we can do a lot of tests faster than many larger, bulkier, more expensive instruments. As well as the incredible power of our probe, we have an LED reader and a patented incubator and shaker that allows us to keep the footprint small. And once again, the benefits of an LED reader are that you don't have to replace the bulbs, you don't have to worry about the bulbs dying out, and you're going to get a much more robust product. With the shaker, we have an orbital shaker, which we've made to try to mimic any type of normal manual processing of an assay. And the onboard convection incubator allows for an even heating across the entire plate. Our intelligent rack system allows you to customize your load, your sample load. So if you are a left-handed person and you'd like to start loading your samples from the left, you can. If you'd like to start from the right, you can start loading samples from the right. It also means that you're going to positively identify all the samples that need to be run with the test. It does not matter where they go, they will always be assigned to that test. Now, once again, you can also turn that feature off if you don't want it, and you can load it just like any other instrument would normally have to be loaded. We are always trying to simplify your experience, and therefore we don't want you to have to use disposables. Disposables cost a lot of money. There are many other instruments out there where you have to buy a disposable for everything. The calibrators, the conjugates, the reagents, and even extra wells to fill the well. Well, because we process everything well by well, you don't need extra wells on the plate. And we build the instrument so that you can load the reagents directly on. If a reagent is in an oddly shaped bottle, we can provide you with disposables to make that possible to put on the instrument. But as I said, we try to minimize ever having to do that. We want to put the cost savings back into your pocket. Also, with the calibrators and controls, they conveniently fit in most of our sample racks, and we even have an extra model of sample rack that allows for many of the kits that we run on the Thunderbolt for their calibrators and controls to be loaded directly on. Many tests can be run on the Thunderbolt at the same time. It all depends on how many calibrators and controls and samples you have to fit within the two-plate space. There are a few limitations for tests being able to be run together, and that is simply incubation times, incubation temperatures, and a maximum of 2 different wash buffers. We have a location for 2 wash buffers on the side, and we have a pinch valve that allows us to switch between those wash buffers. Now, you also do not need to separate those tests by plate. If you had just 4 strips here, you didn't need to run the second 4 strips here. If there's enough room to be fit here, they will be loaded here. Therefore, you can stack all the way across the 2 plates until you have all the tests that can be run together fit together on the same run. Once again, the camera is good for the lab tech to be able to see what's going on inside their instrument when the lid is closed. However, the key feature to the camera is that we can remotely log in and we can observe what's going on within the instrument. And in fact, we have applications on our iPhones that allow us to even log in from our phones. Let's say we're stuck at an airport, we can still help you out and see what your instrument is doing. Now, we believe in having a user-friendly and simple instrument to use. So on the Tools tab, the tech can actually be the one to prime the instrument, home the instrument, align the instrument. You can even manually use all the features like the reader, the heater, the incubator, the shaker. You can use all those features independently if you need to, and you would do that here on the Tools page. Speaking of maintenance, we have a very simple maintenance program. The first thing you would do at the beginning of the day is prime the system with the wash buffer you're going to use. At the end of the day, you just need to prime with DI water. That's it. At the end of the week, there is an instrument alignment, a reader alignment, and just overall cleaning of the instrument that needs to be done. Now, a lot of people are afraid of doing an instrument alignment and are afraid of doing a reader alignment, and most companies don't even allow their techs to do such a thing. However, we made our alignment as easy as possible, as user-friendly as possible, and as intuitive as possible, so that in case something does go wrong, you have the ability to get your instrument up and running again. We think it's horrible that other instruments will crash and that you have to wait for a technician to come out, even if it's just a simple alignment problem. We recommend that in the weekly maintenance you perform that alignment. Therefore, you're guaranteeing that throughout the week you have a nicely aligned instrument. However, many of our sites actually do their alignments at much longer time intervals. But like I said, we recommend once a week. And to me, the best part of that feature is that you have the ability to do the alignment yourself. Therefore, if something gets bumped and something does go wrong, you can realign it and get up and running again. We just want to emphasize the fact that it's as user-friendly as possible and that you have the control as the technician. You don't have to be dependent on us. It's friendly enough to use and friendly enough to service and maintain that you won't have to wait for us every single second something were possibly to go wrong. You can troubleshoot easily and resolve the problem yourself and get the instrument up and running again. In that same regard, this is a very simple instrument to service. Every single component of the instrument is easily accessible by just taking off thumb screws. For instance, on this left side, this whole left sleeve can come off by removing 4 large thumb screws, just like this. The lid can come off, removing similar thumb screws. It's very easy to get to all of our parts in order to exchange them out or replace them if that needs to happen. I hope you now see that the Thunderbolt is an incredibly easy to use, fun to use, and an incredibly powerful tool for any EIA formatted test.